If you have a technology that is quote unquote smart cities, you sure as heck better have tested it in the real world environment.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today in the lobby, Karen Lightman explains the complex relationship between technology and policy at the crossroads of smart cities, and why we still live in, basically, dumb cities, when we've had a lot of the technology needed for smart cities for over 10 years. Karen Lightman is the executive director of Carnegie Mellon's Metro 21 Smart Cities Institute, and as co-chair of the World Economic Forum's Trustworthy IoT Coalition, she is one of the world's foremost voices on transforming U.S. cities into smart cities. Since 2017, Lightman has championed the smart city concept by using the city of Pittsburgh as a proving ground for smart city projects built around improving public life through machine learning. Her work for the MEMS and Sensor Industry Group, or MSIG, gives her a unique perspective on the engineering realities of smart cities, a facet of the conversation that sometimes gets lost in the very public narrative around the futurism-laced vision that can sometimes feel more like the Jetsons than reality. Her body of work can be thought of as the handshake between technology and public policy that smart cities ultimately represent, if they are to be adopted as the norm in the coming decades. According to Karen, our cities should have been much smarter by now. So what happened? Is the delay in digitalization due to gaps in available technology or insufficient public policy? Well, turns out it's kind of a tricky answer, and that's why she's here. Karen, awesome to be here with you, having this conversation. We are in the era of smart. So we're going for autonomy, but we're also going for I shouldn't have to tell you what to do all the time. You do your thing, network of machines, and you get back to me and tell me if there's a problem where I need to intervene. And right. So it's all cool, and we're seeing a lot of it in our own homes. But you've got a very interesting angle on all of this because one of the ways that we can all benefit from smart technology, improving quality of life for everybody involved, is in the context of, we would say maybe smart city or smart municipality, which can mean a lot of things. So for my own benefit and to sort of tee this up properly so that I'm not asking you 90% stupid questions, what constitutes right now a smart city in your opinion, as somebody, a subject matter expert who's informed on policy, informing policy and things, and heading up this great work at Carnegie Mellon?
Thank you. Well, first of all, it's an honor to be with you here, Dave, and thanks for hosting me. Smart is not enough, even, right? I think it's got to be thoughtful and intentional and sometimes transparent enough that you can trust the device. So the work that we do at Carnegie Mellon and at my institute, Metro 21, is we take the technology that's developed at Carnegie Mellon and we co-create and iterate in the deployment of the technology with our deployment and equity partners throughout the design, the deployment, and the evaluation.
Yeah.
So it's and that takes a lot of work.
Yeah,
and it also takes, and
right.
I'm a staff person. I work in those worlds, but then I have to be a translator so that when I'm meeting with community groups where I'm, presenting the work that we're doing on food delivery in a low-income area, I have to be able to bring the knowledge of what I know this technology can do, but I also need to understand where they're coming from, because I understand the supply chain. I understand what's involved in designing the perfect chip. I get it. I get falling in love with your design. and then it has no market, right?
Yep.
I've seen that. I have friends who have had startups that have failed miserably because they fell in love with the design and there was no market.
Yeah.
And the MEMS industry is a great example of like, dead bodies on the side of the road because the market was not there.
Right.
And so this tech push, market pull, and now I'm in this sphere of smart and connected cities and smart and connected regions. And it is really about the market and more. Because as we were saying earlier, is yes, there could be a market, but like, can someone afford it? Like, can a municipality COVID-19, like tax revenue down in most municipalities. Like how are they going to pay? If smart cities were a difficult market to be in before pre-COVID, it is much more challenging now. So that it's going to take a lot of collaboration, co-creation, and partnership. And it's got to be from the chip on up that, we're thinking intentionally, designing in security from the chip on up, using technologies like edge computing to ensure that if you're gathering data, say through digitized imagery, that it's not susceptible to being hacked, that you're doing the processing at the edge. And that all takes, smart chips at the edge that can enable that edge computing, low latency, using less power. All these things are really relevant. And I had a chance to be a part of the beginning of that. So I was in 2000 joining when MEMS was just a technology.
Yeah.
It was used in airbags in like fancy cars like Mercedes and maybe a Cadillac. And now it's literally everywhere. Like there are MEMS chips everywhere and you don't even realize it.
Not an exaggeration. When I worked in the semiconductor industry, I had a VP of sales pounding on me every month to design MEMS accelerometers, 3-axis accelerometers, into toasters and small appliances.
He was a visionary.
That's a good word. Hey everybody, it's Dave. This episode of Moore's Lobby is sponsored by AVX. AVX Corporation is a leading international manufacturer and supplier of advanced electronic components and interconnect, sensor, control, and antenna solutions. Specific to this episode, AVX is actively involved in the continuing development of single-pair Ethernet standards and compatible connectivity products that offer significant space and weight-saving advantages for applications including industrial, process, and building automation systems, smart city networks, and transportation systems. To learn more, visit avx.com. It's interesting to me the position you're in because an engineer comes up hopefully through engineering school or some kind of training like that, and then get started working on designs. You need to solve this problem or make this function work. Here's your budget. They probably don't have it. They're doing everything to specs, right? Like I need the piston to move this many centimeters. And I needed to do it this many times a day under these thermal conditions and blah, 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 blah. What they're not doing is saying, and make sure that the piston isn't inherently biased in its operate. So you come in and you're looking at this, and now you're adding another layer of sort of design criteria to, we'll say, semiconductor manufacturers. It makes me think of Silicon Labs. I had a really good conversation with some folks at Silicon Labs who were specifically talking about, we are constantly looking for ways to make our silicon that's going to be used in connected devices 1,000,000 times more secure at the hardware level.
Right.
Because we know that this might go into something that in the future could be hackable.
Right. And actually, that's where I would answer it. And I would say to build that trust, you need to make sure that it is not hackable as much as you can. Right.
Yeah.
And you've got to be constantly thinking about improving it and updating it. And then the other piece of that is ensuring that further up the supply chain, that they know if you've put in an update or a patch, right? I think that's this trustworthy IoT. I'm part of this trustworthy IoT coalition at the World Economic Forum.
Yeah, you're part of that too?
I'm the co-chair for the IoT, Trustworthy IoT Coalition, and it's got to be the whole damn supply chain from the chip on up to so that the consumer, if my Alexa speaker needs an update, that I'm aware of that it's being done seamlessly or maybe intentionally, so I can say, yes, I want that update, or no, I don't. Because oftentimes, like from the guy who designed or gal who designed that chip, there's no transparency through the supply chain.
No,
it's just like, oh, they're ready. They're already on the next design cycle.
Yeah,
it is about security and safety, and then it's up to the software engineers to build that address issues of bias.
Cloud services and firmware and
right.
Updates over the air, like, oh, well, we just wanted to change how one of the parameters gets updated. Like, well, wait a minute. It's not just affecting a smart factory now. It's actually affecting maybe, safety at an intersection, a busy intersection.
Exactly.
So is there oversight there as well? Or is the pressure mostly on the hardware manufacturers?
Yeah. That's a really good question. And actually, the work that we did with the World Economic Forum started with asking, where are the gaps in governance? Where is the perceived risk and where is the perceived governance of IoT? Where are the gaps? And how do we address those gaps? And now we're in that part of looking at what's the role that the World Economic Forum can play to help inform this, so that corporations, and at the end of the day, willingly and decidedly say, yes, this is important to us because we want to be known as a company that cares about trust. We want to be a company that cares about your privacy.
Right.
This is the question: is where is the role of government, right? And I would say this is a touchy issue. We do live in a capitalist market society, right? And we allow the free market to determine a lot of these things. But the reality is, if there's bias in the market, it's not going to perform efficiently and equitably because of that bias.
There should just there's preserving a free market, and then there's just the diligence of, like you said, sort of an equitable experience by all citizens.
Yeah.
And that should just be like the baseline.
I know.
So
it's not.
When you mention gaps, what are two glaring gaps, and then one maybe not so obvious, maybe a very subtle gap that you've that have been acknowledged?
The one that always is interesting to me is the Ring doorbell. Okay, so that was an example. We did a workshop, literally one of the second to last workshop that I hosted on campus. It was in mid-February of 2020. And it was to break out in terms of in the public realm, in industry, and towards consumers, like, where are the gaps? And this example of the Ring doorbell came up as you're basically, even though you're installing the Ring doorbell on your own private home, the camera is going out into the public realm and is recording people who have not given their permission to be recorded.
Sure.
Right. And then sometimes those recordings are being posted publicly, again, without those people's permission. And sometimes they're being used to solve crimes. Sure, I understand that. Sometimes they're not.
Yeah.
So it's like these unintentional consequences. We need to be aware of them. And honestly, my belief is Ring needs to step up to that and take responsibility for it, and maybe improve the hardware or the software to ensure that, okay, if this person is on your property, yes, you can video them. But if they're on the street, no, that's a public, that is not a place that you own the rights to do a video. And if you're going to post that somewhere else, it's going to be encrypted in such a way that you can't do it. Like there's got to be thought put into this stuff as those unintended consequences come up.
So when we look at scaling up into smart cities now, I think your Ring doorbell is a fantastic example. As you scale up, you only scale the problems that come with it. They don't stay the same. Tell me a little bit about Metro 21, which is what you are involved with now at Carnegie Mellon.
Thank you. So Carnegie Mellon's Metro 21, we take technology that's researched and developed at the university. It could be a piece of software. It could be a new sensor. It could be a new way of doing design and design thinking. It could be a policy. And we deploy it in collaboration with our municipal and equity partners to solve a real world problem.
What you've essentially done is you're the hub of a living laboratory, right?
Mm-hmm, mm-hmm. Yes, I am.
That's very cool.
I sometimes hesitate to say living lab because it's not like we're experimenting on people. Like I think it's more, it's like a living sandbox. Like we're co-creating together. We're playing in the sandbox together.
Learning together, yeah.
We are. And I think, the project that we're doing on food delivery, we just reached a really exciting milestone in southwestern Pennsylvania, working with United Way of helping to deliver 1 million meals to families in need.
What was your involvement?
Yes, I was not making sandwiches, but
right.
what we realized when the pandemic hit, when schools went remote, a lot of kids who in low-income communities, in particular the exurbs of Pittsburgh, not in Pittsburgh proper, they were not getting their breakfast and lunch because they weren't going to school.
Yeah, exactly.
And there were these grab and go locations. And we had 4,000 in Penn Hills, this neighborhood, which is right outside of the city. Penn Hills, we had 4,000 kids that normally would be going for breakfast and lunch and school. And they were only 25 were showing up once a week.
Man.
So that was clearly a gap, and we were very concerned. And so we were approached because we had been doing another project with a group of folks that were working with the schools on optimizing bus routing with 20 municipalities and 20 school districts. And then there was no school. So it sort of became like, we've got this other really big problem. Do you think you can use similar machine learning tools to optimize the delivery of meals to school kids?
Wow. Yeah.
And we said, why not? So we were able to do the COVID word. We were able to pivot real fast, and we were able to work with the United Way and other nonprofits and our Department of Human Services to optimize the delivery of meals to families in need. And it's expanded now to 2 other communities, McKeesport and McKees Rocks, which are some real down and out communities who have had the stuffing knocked out of them, never really recovered after the decline of the steel mills that left in the 70s. Okay.
Yeah.
And so it's been extremely rewarding. Our project alone is helping to deliver 8,500 meals a month.
Using data.
Using machine learning algorithms. Yeah. And it's continuously being optimized, and we are continuously adding more information from the community. I meet with community groups, 3 separate community groups 3 times a week to ensure that the algorithm has the most current information, and that we can redesign the route to better serve the community and the needs.
This is the only possible way. I've been like here in Denver. My wife and I have had so many conversations, at dinner or whatever, just around this very issue of there are thousands and thousands of students who relied on those meals at school. And how do we scale this to get them, and this is one way to do it.
Right.
With this work, it's so massively important you're demonstrating that it's doing something even as important as nourishing people in your community. Have you been able to export the work that you're doing to, say, other countries or other smart cities around the world?
Well, we're part of something called the Metro Lab Network,
Okay.
which is a coalition of 30 plus universities and municipalities, and it is worldwide. And we collaborate through the Metro Lab Network as a way of sharing best practice and co-creating with a larger audience. Because a lot of what we want to do, honestly, is open source. Because this is the kind of stuff that we don't want to, it's not proprietary. Like, we want to feed as many people as possible. We did a project at the city of Pittsburgh on optimizing the identification of commercial buildings most at risk for fire. There's like 6,000 commercial buildings in the city of Pittsburgh that require an inspector to inspect and make sure it's not at risk for fire. I think there's like 5 inspectors, some ridiculously low amount. And what we did in using a lot of open source and then some proprietary information that's pretty standard, like former inspection data, we were able to create a tool, a decision tool, to help inspectors say, okay, I've got 20 buildings on my docket. Okay, this one is the most at risk. And so we were able to decrease the rate of fires in commercial buildings and they were able to predict 85% of fires in those commercial buildings using this tool. Basically save lives through AI. And this is open source. So this is software that we basically developed with the public safety department at the city of Pittsburgh, and now it's being utilized in other cities.
So it seems to me one of the strengths here is that you seem to have engineering students sort of commingling with, we'll say, policy students. Is that?
Oh, absolutely. So actually, one of our mantras, we have a few, but it's this idea that we play at the intersection of technology and humanity, and I like to flip it as humanity and technology. And it's also about technology, it's about people, and it's about policy. So a lot of what we try to do is these demonstration projects in the sandbox, and then we use that as a way to inform policy and investment decisions. So
then with all of that crazy, just mental, like the cool intellectual energy that you have going on there, surely this is spinning up. Are startups kind of coming out of this? I imagine this almost being like an incubator that spins out all these startups.
I keep losing count, but I think we've helped, between myself and my sister organization, Traffic 21, which is focused on intelligent transportation systems. We've helped launch 8 startups in varying degrees of success, I must say.
Sure.
But they all started here in Pittsburgh, and we, all through this whole what we call RD&D, research, development, and deployment model, where it's like there's a stage of technology readiness level, TRL, and so we're in one of those later stages, maybe it's 7, where just before you're going to say, hey, this is a company, you've got to test it in the real world. And if you have a technology that is quote unquote smart cities, you sure as heck better have tested it in the real world environment.
Oh yeah.
Because, so we have Roadbotics. It's a great startup that is now using artificial intelligence, machine learning, and digital vision to better understand infrastructure. So your potholes, so your beautiful potholes and infrastructure like signs and roads and things like that.
Yeah.
It's able to just the human is driving the car or the bus route, and it's capturing that information and using that information to inform and then categorize the health in a color-coded system of green, yellow, red, to help communities and municipalities decide which neighborhoods, which streets need to be repaved, because paving is power.
Oh, yeah,
right? And
absolutely.
and so if you can make that process transparent, then it builds trust in a community. Because anyway, I could talk forever, but that's one example of one of our startups that's doing fantastically well. And
Yeah.
I don't know, I thought they were like in 300 communities worldwide. And their humble beginnings were with us here at Metro 21.
The other thing that's, if a city's old enough to have crumbling infrastructure, well, now we're talking technology retrofit. Like you can develop the coolest, most sophisticated, elegant, theoretical systems, what you're doing, but obviously you're also designing them to have a real impact. So these need to be adopted and they need to become the elements that are the ingredients for a smart city. But you also need to be mindful that you're retrofitting these old cities. And I know from retrofitting a home, my home was built in 1996, and sometimes it sucks. What is the technology that is most realistic right now that will help us equip our cities with the hardware and the software infrastructure that is necessary to collect this sort of data securely, process it and analyze it ethically, and then act in a timely manner?
That is the holy grail question.
Couple of Raspberry Pis and
Honey,
yeah.
yeah, that's exactly what we're trying to do. And I think, we look at things in a system of systems approach, because so many times it's silo, silo, silo.
Yeah. Would you please help me to understand what might pave the road to ubiquitous smart cities, and what might be the role of our Double E audience in making that happen?
Yeah, those are great questions. And I think it's interesting because it also reminds me of back in my MEMS days that oftentimes it wasn't a need for new technology. It was sort of like this nascent technology waiting for connectivity,
You're right.
waiting for something like Bluetooth to enable like this whole new. So I think now we have this space where we're waiting for 5G, we're waiting for ubiquitous broadband.
Hmm.
And so then those awesome sensors can work in concert with digital cameras and edge computing, and higher processing speeds can enable edge computing, but it only works if they're connected, right? And it needs to be done in a safe, secure way from the chip level up. So I think it's more of what we used to call sensor fusion, like this idea of fusing and connecting lots of different devices through a platform that's interoperable. So, folks like the Zigbee Alliance are really important, and IEEE
Mm-hmm.
creating interoperable standards so that devices can truly talk to each other in a secure manner. And then there's power is really
Right.
important too, because you can have a fantastic street light, and if the power source isn't enough to supply to all those sensors, or it doesn't reach those sensors, and if it's not secure, you're not going to connect autonomous vehicles to it.
Yep.
So
Yep.
there is that level of that interoperability, that security, that safety is so important. And then there's no platform. I think the Trump administration made a decision not to legislate what kind of system it would be, if it would be, the Qualcomm way or whatever.
Mm-hmm.
And so they said, okay, let's just let the market decide what it's going to be, if it's going to be DSRC or if it's going to be another technology platform. Well, guess what? Companies are doing both because they don't know where the market is going to go. So
Yeah.
I think the connectivity, the power, like there's like, I used to call it like the three-legged stool. Like yes, it's the performance of the device and all that, but it's also safety and security, and it's power, and it's connectivity. Like it's all of those things have to be working if you're going to have a true Internet of Things with connected autonomous vehicles, with connected transportation and connected humans. So I encourage engineers to think about it holistically and break down barriers. So talk to UI, you talk to designers, talk to software, talk to folks who work in cybersecurity, talk to humans that maybe don't look like you. So I think that's what I would encourage engineers to do, is get out of their silo so they can have a more holistic, integrated approach. And I think the role of groups like a Zigbee Alliance, even CTA that does CES, is doing some work in this area, and the work that I'm doing with the Trustworthy IoT Coalition with the World Economic Forum, those are really important too. You cannot do this alone.
Mm-hmm.
Even companies like Google can't do it alone. My advice is make friends everywhere.
It's such great advice. 20 plus years into the industry, I'm fully appreciative of that as well. And it's funny, engineering behavior, we tend to like to say, no, I can solve this. Everybody just kind of get out of my way.
I got to engineer my way out of this box. I can do it.
Right.
I've got the most beautiful chip.
And shoot, I need a friend to tell me how to connect it to their chip. Oh, now I see. Are there, not to put too fine a point on it, but will the connectivity in smart cities, especially when you're talking autonomous vehicles, and, it's not just smart buildings talking to street lights and blah, blah, blah. Is it going to be cellular connectivity on these backhauls, or do you anticipate a combination of cellular plus maybe low power wide area network like LoRaWAN or?
Absolutely. Yes. It's going to be all of that. It's going to be cellular. There's going to be a component of terrestrial and extraterrestrial, depending on what you need. But for connected autonomous vehicles, when you're talking about saving lives, there can be no latency when you're talking about connected autonomous vehicles and people's lives at stake.
Absolutely.
So it's got to,
No latency and full reliability. And one of the things off in the weeds here that always concerns me is smart cities are great when there's not a rolling blackout going through the territory, or what are the, I guess you need to be designing for the failure modes.
Oh yeah. Oh my gosh, Texas, you were warned 10 years before. They were warned 10 years before, and they continued to deregulate, saying, oh, the market will take care of it.
How far away are we from practical smart cities being ubiquitous, commonplace? Is this a generation from now? Is it a decade from now?
I think the key thing is, we already have aspects of smart cities already, and it's the digitization that's really important. So I feel like there are pieces and parts. The issue is nothing's talking to each other. Everything's disconnected oftentimes. And so how smart is it if it's a silo, right? And so, going back to that, it's really important. You cannot do this stuff alone. You've got to do it in collaboration, in partnership. Groups that are leading, there are groups that are leading this. I know standards is oftentimes called the S word because people don't want standards. They think it stymies innovation, but you can only innovate so much if what you're innovating is in a silo. So I think in 10 years we will have, I thought we'd be there, honestly. 10 years ago, we had the technology. We had things like Bluetooth and Zigbee Alliance doing some great work, and LoRaWAN. We had a lot of that, but we've just got a lot of silos. And we also have a democracy, and the people have rights. and so I'm hopeful that in 10 years we'll have connected autonomous vehicles in some places. Will I be able to drive from my house to my parents' house in Connecticut autonomously? No. But there will be aspects on the highway where I can probably just chill out and take a nap. And my vehicle is connected because the highway is connected and has high-speed ubiquitous broadband. And trucks will be able to do that. And so we'll have lower emissions, all that good stuff. But then when I'm on, country roads in Connecticut, I'm going to have to drive, thank God, because I love driving those country roads in Connecticut. So I think there will be pieces and parts. There will be more pieces and parts. But if we continue this isolation, working in silos, we won't be much further along.
Well, I want to thank Karen Lightman for making time to chat with me today, and be sure to subscribe to Moore's Lobby on any of the major podcast platforms, Apple, Spotify, Google Podcasts, to enjoy new episodes every 2 weeks with industry experts from world-renowned companies who join us to chat about leading-edge technology and engineering topics. You can also follow us and catch prior episodes on allaboutscircuits.com. Thanks for listening.